দেখো স্ক্রিনটা দেখা যাচ্ছে?
হ্যাঁ স্যার।
Yes, sir.
সো আমাকে বলবে কখন স্টার্ট করব। বাকিরা কি জয়েন করে গেছে? Today I will discuss about the fuzzy logic. Why fuzzy logic
স্যার একজন জয়েন হতে চাইছে।
করুক না, দিয়ে দিয়েছি সবাইকে, অ্যাডমিট করে দিয়েছি। এখনো আসেনি তার মানে তার রিকোয়েস্ট। Okay, so today's topic that I will discuss, that is fuzzy logic. Fuzzy is basically the part of a mathematics, and mainly in AI there is a huge application of fuzzy. What is the concept of fuzzy? That is mainly to deal with the uncertainty, vagueness, uh, impreciseness, and inexactness. I am changing the slide. Is it visible? Just tell me.
Yes, sir.
Okay, so the picture that you have seen is Professor Lothri Jade, the founder of fuzzy model, and it is in the year 1965. And another scientist, Mamdani, who has actually applied this fuzzy in a engine control. I think all of you are aware of this control system. So any kind of control system, they have applied that fuzzy in the year 1974. And after that, there is a huge around of recognitions done in case of fuzzy logic and fuzzy related mathematics, and that's why in Berkeley in the year 1990 1991, Berkeley, someone wants to join, hold on. In Berkeley there is a BISC, that is Berkeley Supercomputing Research Center, where there is extensive work has been done in the various fields where fuzzy logic has been extensively applied. So two things are very important. One is the fuzzy, another is a crisp. So what is crisp? Crisp is very straightforward. Last day we had a discussion about the clustering algorithm, and you can see that there is a partition clustering algorithm. That means either, if suppose you want to group, and you want to group based on the subject elective papers, and some elective papers say neural networks, some of you have taken, and other people have taken some cyber security. So this group is totally well separated because there is no such overlap. It's quite clear. So either you are in set 1 or set 2. Set 1 may be cyber security, set 2 is the what I said, that is any kind of elective paper related to AI, that is a neural network. So either it is 0 or 1. If you are belonging into that group, it will be a 1, and if you are not belong to that group, it will be treated as a 0. So that's why it is comes, that is a crisp. This is quite clear. Now a lot of people wants to join. Total strength of this class, can you tell me?
30, sir.
I think we have to wait again. Wait. 26 জন হবে না 24 জন। কি করব, স্টার্ট করব আবার ওয়েট করব? List of history that crisp means that clear, clean or sharp. That means either anyone can belong to that one group or not. So that is crisp. But why fuzzy comes to the picture? Because suppose if you have some kind of no man's land, and some people will be there, right? So no man's land means that is not the part of two countries. That is the border line, or this no man's land. If someone actually there, then both the country can claim that they are in our zone, right? Or both them claim they are not in my zone, right? So there is some kind of uncertainty or vagueness or impreciseness or inexactness in the data set. And if you just look at any kind of some sort of this type of uh, decision making capability or decision making theory, then we have to go for the fuzzy logic, or this is called soft computing approaches. Another example is that whatever we have done, that is the partition clustering algorithm. Suppose uh, the clusters are overlapped, big overlap. One part is overlapped, right? Some portion. Then the points or objects belong to that overlap part or the common part will be treated as uncertainty, because you can't take any kind of robust decision that this particular point or objects will be in cluster 1 or 2, because they are belonging to the both the cluster in the overlap region. So in that case you have to take a decision that how I can put that particular object to which cluster. So then uncertainty comes to the picture. So if you face such kind of problem, then fuzzy logic should be the best possible technique to apply. So this is the situation. That means it doesn't matter that you have to apply the fuzzy logic without sensing the data. That is quite fishy. But at first you have to understand what is the nature of the data, what is the pattern of the data that you are going to handle. Then based on the nature of the pattern of the data, you have to decide that whether the fuzzy logic will be applicable or not. So this is the big thing, and most of the cases we have seen that fuzzy is there. So if we just amalgamate fuzzy with the other system or other technique, then it will be. It sounds like a very good terminology. Then I think my paper, my work will be accepted. That is not the thing. That means your data set is not suitable for the fuzzy logic, but we are forcefully going to apply the fuzzy logic. So that's why some kind of advice you can just take it as that first sense the data, or nurturing the data, or examining the data, identify the patterns, or understanding the pattern of the data. That is the most important thing at first. After that you have to decide whether fuzzy logic or uncertainty is there or not. So that is the fuzzy. Fuzzy means unclear or ambiguous, or you can decide these four very important properties: uncertainty, vagueness, impreciseness, and inexactness. So there is a fuzzy set, and look at that. Another example is there. Crisp means a liquid, yes or not. But if we go for that any kind of fuzzy answer, like maybe, may not be, absolutely, partially, etc. Right? So the example is look like this: is the person honest? How do you decide? They're extremely honest, very honest. So sometimes some truth can be hidden uh, due to some restrictions, but we can't say it straightforward that honest for sometimes, depending upon the situation. So in this way you can score. For example, rainfall. Last few months there is a huge rainfall in Kolkata and surrounding areas, right? So we can't talk like this that 4 millimeter rainfall or 10 millimeter rainfall, something like that. Yes, it's heavy. It's bit now last 3-4 days it's a bit less rainfall. So in this way you can represent, and those terminologies that very heavy rain, light rain. So these terminologies are called the linguistics. So this is the way to represent fuzzy, and most of the cases in regular language, whatever the natural language that we are going to talk, or any kind of communication, most of the cases we are using this fuzzy terminologies. So this is the entire fuzzy framework. Look at that. The fuzzy elements are there. First input data set, then fuzzy elements, then fuzzy sets, and then fuzzy rules, and then from fuzzy implication or inference. Inference means if we want to draw some sort of conclusions, and then fuzzy will be feed into the fuzzy system, and finally it will be the output. So this is the entire fuzzy framework that you have to build, and after that you have to implement it. Now this is the representation of fuzzy logic. Look at that. X is the universe of disclosure where set A defined as this one. And this big thing is that mu x, very, very important. Mu x is the membership function. That means we have a data, but in which particular function it represents. That can be in the user's hand. So it may be Gaussian, it may be triangular, it may be sinusoidal, it may be trapezoidal. So a lot of membership functions are there, and based on that you have to decide the nature of the data is this way. So these two things are very important, and this mu x will be represented. That y-axis is basically mu x, and x-axis is your data. So this way the fuzzy set will be presented, and this is called the membership function. If you go for the y-axis, this membership function corresponding to x, the membership values will be belonging to 0 to 1. What is the meaning of 0 to 1? Just if that membership value tends to 0 or 1, that means fuzziness will be decreased. Please note it down. If the membership values move towards 0 or 1, that means fuzziness will be fuzziness decreased means it will be going to be certainty. Certainty means you are going to take a robust decision. Now if it moves towards 0.5, between 0 and 1 there is a 0.5. If the fuzzy membership value tends towards 0.5, this means fuzziness going to increase. That means that is much ambiguous, or we can say that uncertain, hard to distinguish. So this interpretation is very important. Why it is mentioned that mu x in between 0 to 1. If it moves towards 0 or 1, that means fuzziness going to decrease. That is means minimum. That means you are going to take a certain decision. But if it is moved towards 0.5, then fuzziness is the highest level. That means it will be ambiguous, or we can say it's a very much unclear. So look at that examples: young people, old people, kind people. So these terminologies are very important, and you have to define with the help of the membership function. Little bit code this way. So let's explain with the help of example before going to that part that I told you, crisp versus fuzzy. That comparison is very important. Crisp that I told you, simple, that is binary, yes or no. But in case of fuzzy, you have to redirect the entire thing with the help of a membership function. So this is the tuple, that is the S is the data set, and mu is the degree of belongingness, that is also known as membership. So let's see that A is the fuzzy set, and X is the data values that will be represented by X-axis, and mu X, that is the membership value of X. So corresponding to each X value in the X-axis, you will get a Y value, and that Y value is nothing but a membership values. So that will be represented in this way. So look at that example. That example is very important. Is it visible, this example? X equal to all cities in India. That is the universe of disclosure. And A equal to the city of comfort. Now I want to find out, or we want to find out the city of comfort. And it has been mentioned in this way. New Delhi 0.7. 0.7 means degree of, please note it down. The first one is the data value that has been mentioned in the X-axis. And second one is the Y, corresponding Y value. Y value means membership value. 0.7 indicates degree of truthness or membership value. So membership value 0.7 means that is city of comfort is almost 70%. We can interpret in this way. Bangalore 0.9 is the maximum. 90% is very comfortable. Then Chennai 0.8 is also very comfortable. Hyderabad 0.6. Now it tends towards 0.5. 0.5 means it's hard to distinguish. It's hard to distinguish, or it's hard to take a decision that whether it is a comfortable city or not. But it's very much uncertain. Kolkata 0.3, that is not comfortable at all. Not comfortable, not. Kharagpur 0. So in this way, that means it is not at all comfortable. So in this way, you can just judge that whether the city is comfort or not. So this is the degree of truthness or membership, where the entire set A, this is the fuzzy set A, can be represented in this form. So this is the representation, or these are the functions. Look at that. This function we are talking about age, and this one is the mu, and this is the function. So let's go for the another example. First one is the support. These two properties are very important. Support. What is support? This is the x-axis and this is the mu that I am telling you. And support of A means the fuzzy set. How do you interpret it? The support of fuzzy set A is the set of all points x belongs to the capital X such that mu x greater than 0. That means set of those set of points that is greater than 0, for which set of x values the mu values will be greater than 0. Then this particular set of x values will be denoted as support. Similarly, the core of the fuzzy set is set of all points x in X such that mu x equal to 1. That means for set of x values for which the corresponding mu values reach to 1. Look at that. Only this red color marked. Is it visible? Red color this set of x values.
Yes, sir.
That means for this set of values, every value, if we just go for, then it will reach the membership value 1.0. So that is the core of the fuzzy. So which one is the core? This set of x values for which mu values are 1. So it's very similar to a trapezoidal. I think all of you are aware of this trapezoidal function. This one is the Gaussian, bell-shaped. So next one is the normality. It's also very important property. The fuzzy set A is normal if its core is non-empty. That means there is no such set of x values for which it will reach the 1. Non-empty, right? Fuzzy set A is normal if its core is non-empty. Non-empty means at least one value there will be. In other words, we can always find a point x belongs to 1 such that mu x equal to 1. Because this normality is false, because at least one value should be there for which we will find mu value will be 1. But in this particular example, there is no such value of x for which it will reach 1.0. So normality of this fuzzy set is false. What is crossover? Crossover is these 2 points. Look at that. Fuzzy set A x belongs to x. Mu x equal to 0.5. That means for which set of x values it will reach the 0.5 mu values. This is called the crossover point. Fuzzy singleton. The fuzzy set whose support is a single point, that means only one value is there for x value for which it will reach 1 mu value. This is called fuzzy singleton. Now, fuzzy set can be represented one way I have already mentioned. Another way you can represent, look at that. A is the fuzzy set where for x1 you will get mu a x1. This is the membership corresponding to the x value x1. Plus, this plus and this slash doesn't indicate that there is a division or this addition. This is a set representation. In this way you can represent. This slash is known as separator and plus is logical OR operation. If x is continuous, then in that case, summation will be represented or replaced by integration or integral sign. This is another way to represent. Please note it down, this part. Done. Okay. Have you written it, all of you?
Yes, sir.
So these are the operations on the fuzzy sets. Look at that. A and B. If this two, A is a fuzzy set, B is the fuzzy set. These two are called the equivalence or equal to if and only if the membership value of all the x values equal to the membership value of all b values, right? Membership B. Implication. Implication means just this arrow. How do you represent it? A is basically the implications B. So mu A x should be less than equal to mu B x. Complement, that is the negation. Not. Not means how do you represent it? Mu A x not, that is 1 minus mu x. Union, very very important operation. Union, which is also equivalent to OR operation. Disjunction, that is A union B. How do you represent? This is the OR operation. Look at that, OR signature is there. That is maximum of these two mu values, mu ax and mu bx. Intersection, AND operation, that is called conjunction. This is the AND, intersection. So how do you interpret it? This is the AND operation. Minimum of these two. So look at that, the pictorial or visualization of those two operations, those three operations. Upper left means this part. This is the AND operation. Look at that. He said AND means it's an intersection. Only this part will be output. Only this part. I am just moving the mouse. Is it visible?
Yes, sir.
And lower left is basically OR operation. OR means is basically the union. Look at that. The entire boundaries. So the common part will be just overlapped. And negation will be represented by this because 1 minus. Just you calculate it, you will get this type of shape. This particular slide is very important. Lot of mathematical or numerical problems can be evaluated through this particular operations. Is it okay? Hello? Should I move?
Yes, sir.
Now look at that example. The universe of disclosure means x equal to, there is the universe of disclosure. This is the set of the 5 persons: Masahiro, Suoshi, Akua, Shaburo, and Masami. So two things are there. One fuzzy set is for the young persons, and another fuzzy set B, basically tall persons. Now, how do you define the second term, representation that just I told you? The A fuzzy set will be defined as 0.4 / Masahiro. That means A means young person. So 0.4, that means it's not so young, right? That Masahiro, based on that value. Because if The degree of truthness close to 1 or 1, that means it's definitely youngest. So zero point 0.6, again it's white. Zero point 0.4 and zero point 0.6, it's basically the uncertainty is there. Shuoshi. Aqua, zero point 0.8, that means almost very younger, we can say. 1.0, that is the youngest. And zero point 0.9 is also very close to the youngest, right? In this way you can represent. Similarly, B is the tall person, is short. Is zero point 0.3 means it's not a tall person at all. 0.5, that means again uncertainty, not at all, not as shorter. So Aqua, zero point 0.9 means is the one of the tallest, right? Also zero point 0.9 Masami, tallest, also the tallest. So tallest or maybe very close to the tall person. And then Samuro zero point 0.6 means it's also the bit of uncertainty, right? That means 50-50. We can't say completely tall or short, right? So these two sets are there. Now you have to do the operations. That means a or operation or and operation. A or B, that means A union. Just go to the previous slide. You can see A union B means or operation or disjunction. What is the operation we have to take? Maximum of these two. So let's see how do you compute. A union B means or operation, maximum of these two. 0.4 and 0.3, maximum of these two is 0.4. 0.6 and 0.5, 0.6 will be there, maximum. 0.8, 0.9, 0.9. 1.0, 0.6, that is 1.0. And finally 0.9, 0.9, same, that is 0.9. Now if we do the AND operation, that means intersection, what is the intersection? Minimum of these two, look at that. So minimum of these two will be 0.3, look at that, 0.4, 0.3, 0.3, and so on. So what is the conclusion? Conclusion is that if we take the operation of A union B or A intersection B, A union B is also a fuzzy set and A intersection B is also a fuzzy set. So then what will be the membership values of this one? So that's why we need to calculate those things. Got it? Is it understandable?
Yes, sir.
Okay. Next, look at that. In terms of numerical values, we have done this two. Just observe it or just try to understand it. If any glitch, please tell me. Read it carefully, / and all. Please tell me whether it is okay or not. Understandable or not. Set A, fuzzy set A, x1, comma 0.5 means 0.5 slash x1 separator plus 0.1 slash or separator x2. In this way, you can also represent. And C is the resultant fuzzy set. If you do this operation, A union B will get C. So C is also the fuzzy set, and these are the set of membership values.
Okay, sir.
Is it correct, all these values? Is there any error values, or is it matched with your calculation?
Yes, sir.
Okay. So this is the complement. Look at that. Complement algebraic product or vector product, and this is a scalar product. That means alpha will be multiplied with this fuzzy set or fuzzy set A, then this one will be representation, and if it is a vector or algebraic product, then this one, the corresponding membership will be multiplied. And what I said that in case of complement, 1 minus that value. So x1 comma 0.5. So negation or complement of A, fuzzy set A will be represented by x1 comma 1 minus 0.5. 0.1 means 0.9 will come. 1 minus 0.1. Similarly, x3 0.4, that means 0.6 will come. And this is the representation, visual representation.
স্যার এটা কি সিমিলার টু প্রবাবিলিটি, কারণ প্রবাবিলিটি তো
No,
1
probability is something different. Probability is something different.
ওকে স্যার।
Various kind of operations of two fuzzy sets. I'll share this slide. In that case, you can take it. So this most of the cases you can see our old XOR operation, difference, disjunctive sum, all those things are there. So these are the basic fuzzy set operations. Cartesian product A cross B. So two fuzzy sets are there. One on X, another is the variable Y. So look at that. These are the not non-uniform distribution. That means A fuzzy set consists of 4 variables. X is the variable, that is 4 values are there, x1, x2, x3 and x4. Whereas B consists of 3, y1, y2 and y3. Now in that case, how do you represent A cross B? A cross B will be represented by minimum of these two, mu A and mu B. So it's nothing but a matrix representation. Look at that. So 4 cross 3 matrix, right? 4 x1, x2, x3, x4, and this one is y1, y2, y3. So minimum of mu A and mu B. So minimum of, that means x1, y1 will be compared. Minimum of this two will be 0.2. That means x1, y1. This is the first row, first column. First row, first column. x1, y2. x1, y2 means this one. 0.2, 0.6. So 0.2 is the minimum. x1, y3. 0.2 is coming. x1, y3 means 0.2 and 0.3. So 0.2 is coming. So in this way, you can represent the Cartesian product between two fuzzy sets A cross B. Please check the other values whether it is coming perfectly or not.
Yes, sir. Correct.
Okay. So these are the traditional set theory properties. Same thing will be applicable for fuzzy sets. Please look at this one. All these fundamental properties. C means complement, this C, complement or negation. In our digital logic or any kind of logic that we are using bar, A bar, B bar. So this one, A bar, then so here we can mention with the help of C, complement. And De Morgan's theorem is also there. There, what is the critical thing? Two terminologies are there. You can please note it down. Basically, two processes. That's why it is so popular or familiar. One is called fudgification. Very important. Fudgification. One process named as fudgification. What is the meaning of fudgification? That means there is a crisp value, but the nature of the data set, it suggests that there is a certain kind of uncertainty, right? There is a certain uncertainty is there in the data set. So to remove that uncertainty or take the decision so robustly, the crisp value will be represented in form of linguistics. So crisp to fuzzy conversion, this is called crisp to fuzzy conversion, is known as fudgification. What I said, crisp to fudgification is known as fudgification, provided there should be some kind of uncertainty present in the data set. Opposite or vice versa. That is fuzzy data set, and you want to convert it into crisp. Fuzzy to crisp, that conversion is known as defuzzification, just opposite, defuzzification. So first we'll start with the fudgification. What is the challenging task in this fudgification process? That means, depending upon the nature of data, the designer or any kind of AI engineer, say, or subcomputing engineer, they have to decide which type of membership function will be suitable for this data set. So let's see with the help of an example. Look at that. These are the different type of membership functions that we are talking about. Triangular, trapezoidal. This is bell-shaped, non-uniform shaped, right? All these are the various kind of membership functions. Tangent, hyperbolic tangent. So these fuzzy functions are very popular. That I told you, triangular membership function. Not only you have to represent in form of this pictorial representation or visualization, but you have to mention with the help of this mathematical interpretation. This one, also this one. Look at that, Gaussian, generalized Bell function or Cauchy membership function. Very, very important function, Gaussian or bell-shaped. Sigmoid. Most of the cases, this one is extensively used in case of neural network. Discuss about that. And sigmoid function is very, very important. It's also known as quotient function or logistic function in case of backpropagation neural network learning. So look at that. This is S. That's why it is known as sigmoid. Look like S. Now this is the problem statement. Please note it down, this statement. First try to understand the whatever the mentioned in the problem statement. Age 0 to 35 youngest, 20 to 60 middleest, and 45 to 80 oldest. Draw the membership card and define the membership function of the age. Please note down another example. 0 to 35 youngest, 36 to 49 middleest, and 50 to 80 oldest. Draw the membership card and define the membership functions of the age. Two questions are there. One question that has been mentioned in your slide, whatever I'm going to share, and another question that I am actually going to tell you, that 0 to 35 youngest, 36 to 49 middleest, and 50 to 80 oldest persons. So draw the membership card and define the membership functions of each. Can you tell me what is the difference between two sets of problems?
স্যার এখানে এজগুলো ওভারল্যাপ করছে একে অপরের সাথে, মানে গ্রুপগুলো আর কি।
যেটা আমার পিপিটিতে দেয়া আছে, তাই তো?
হ্যাঁ।
ভেরি গুড। আর একটার ক্ষেত্রে যেটা সেকেন্ড প্রবলেমটা দিলাম,
ওখানে ডিসজয়েন্ট আছে।
ওখানে কি আছে?
মানে সেটগুলো ডিসজয়েন্ট আছে, ওভারল্যাপ নেই।
ওভারল্যাপ নেই। So according to the definition of fuzzy and crisp, crisp আমরা প্রত্যেকে জানি কি, এর মধ্যে কোনটা ক্রিস্পের মধ্যে পড়ছে বলতো?
সেকেন্ড
is crisp. Very good.
Yes.
The secondটায় তার মানে young, middle aged এবং old clearly defined. All of you agree?
হ্যাঁ স্যার।
Second, young, middle-aged, and old clearly defined. But in this case, young, middle-aged, and old clearly defined নয়. Can you clearly define নয়? So 0 to 35 young age, right? 20 to 60 middle-aged. So what we have seen that in between 20 to 35 there is an overlap. So the persons who have the age in between 20 to 35, they are also belonging to the middle-aged as well as the young age. Got it?
Yes, sir.
So similar sort of things we are getting in case of 45 to 60. They are belonging to old age as well as the middle age. Now, this is the big challenging task, that how do you interpret it visually? First, you have to represent the function visually. Then from this visual representation, you have to draw this function mathematically. So let's see. So x-axis will be represented by this age, right? So if we do this, look at that. 0 to 80, the entire range. 0 to 80, the entire range. 0 to 20, that means in between 0 to 20, if we go through this one, every time you will reach 1 in case of youngest. So that graph will be continued up to 1. Look at that. Because there is no other, it's purely crisp. After 20, then you can see the graph, this is the slope, comes down to the 35. Because after 35, there is no question of youngest. After 35, it is purely middle-aged or old age. So look at that. After 35, it will be 0. Now, how this one, this is the graph of this line. This line, please concentrate on my mouse movement. This line is called the young aged membership curve. Similarly, after 45 and in between 60, there is a overlap. And after 60, there is a purely old age. So look at that. After 60, any value, it will reach to the old. But in between 45 to 60, there is an overlap. So it will be moving up to 60. After that, there is a purely 1. So purely crisp. So these two curves has been drawn, one for the young membership, another for the old membership. Now, third one, middle-aged. Check from this definition. In between 35 to 45, there is no such overlap. So you can state all those set of x values, you will reach easily hit to the 1. So it is called plug. In between 20 and 35 and 45 to 60, there is overlap. So this middle-aged has two different overlap region, one with young, another with old. So this is the representation of visual representation of three different curves: youngest, middle-aged, and old-aged. Now, what is the shape of this function? Shape of the function is trapezoidal. So definition of this problem statement forced you to draw the trapezoidal membership function. That is the most challenging task. Got the idea?
Sir.
Yes, please.
Sir, A1, A2, and A3 are three different membership functions.
Three different membership functions. One for the youngest, one for the middle-aged, one other for the oldest.
So this is the combined graph. Combined
graph. Because there is an uncertainty in between young and middle-aged and middle and oldest. That's why uncertainty is there. That's why we are going to draw this membership.
Okay, sir.
Now, how do you define? Suppose I have a age, or any person have a age in between 20 to 35 or 45 to 60. Then how do you represent it? With the help of a triplet. Triplet means with three values: young values, middle value, and old value. Look at that. Look at that representation. A1 basically represents the young age. So A1x, that is the membership function. Mu1x, whatever we have defined earlier. Mu1x. Look at that. It's 1 when it is less than x equal to 20. Yes, it's true. If x less than equal to 20, then it's purely 1. 0 when it will be 0 if x greater than equal to 35. Yes, there is no such curve. Now this one is important. How do you interpret it? In between 20 and 35. Look at that. If it moves towards 35 from 20, that means this slope will be comes down. That means value will be lesser, new membership value. So we have taken that difference, 35 minus x divided by this difference, 35 minus 20. That's why 15 is coming. Is it understandable? You just take a test that if x equal to 25, 25 belongs between 20 and 35. If x equal to 25, so that value will be 10 by 15, that is 2/3. 2/3 means 0.67. And if x equal to 30, then that will be 5 by 15, that is 1/3, 0.33. Yes, membership basically reducing as per the nature of the curve. So it's true, that representation. Similarly for old, in case of old, please check this one. When x greater less than equal to 45, then 0. If x greater than equal to 60, then 1. Otherwise, look at that. In between 45 and 60, the opposite. If it moves towards 60 from 45, then membership value increases. So we have taken x minus 45 divided by 15. Again 15 comes, means 60 minus 45. Check.
Yes.
Similarly, it bit quite difficult in case of middle age, 2 overlap region. So 0 and 1 is clearly defined. But how do you represent x minus 20 by 15? That means opposite. If it moves from 20 to 35, then membership value increases for middle aged. If it moves from 45 to 60, then membership value decreases for middle aged. That's why these two representations are there. So this is the complete solution. If someone asks you, this is the problem statement, you have to draw the membership function. At first you have to draw the membership function. First you have to sense the data. What we did basically, we have basically sensed the data. After that we have decided, yes, membership function required. What is the nature? That forced you to take this trapezoidal membership function. And after that, based on the nature of the membership function, you have to interpret to the mathematical representation.
স্যার ওই 15টা কোথা থেকে আসলো? ওটা কি ওই মাইনাস?
Yes, nothing. There's this two. 60 minus 45.
হ্যাঁ হ্যাঁ, মাইনাস করে।
Similarly, 35 minus is a mod. This one is all are mod. Okay. Anyone, you can write x minus 35 mod. Absolute. Okay. And keep it in mind. If you mention x less than equal to 20, then another part. Look at that. When x less than 20 and 35, no equal to is there, because you have already mentioned this condition over here. So no need to put equal to over here again. Okay.
Sir, one more question.
Yes, please.
Sir, here we have two overlapping sets. We have two intersection sets. So instead of taking them as intersections, if we define them as new categories, will that be an example of defuzzification? For example, we take... Yes, sir.
Defuzzification is something that there are multiple sets are there. Yes, you can do this, but you have to put some sort of center. If you want to center of sums, you have to find it. So multiple sets are there. They are overlapped. Yes, true. They are overlapped. But you want to find out a single value. But here there is a clear definition of these three linguistic: young, middle-aged, and old age. There is no other linguistics, right?
Yes, sir. I was saying, sir, if we define two new linguistics such as young, middle-aged,
that provision, yes, that provision is not there. So you have to stick on this young, middle-aged, and old age. So you can't introduce this one, right?
Okay, sir. Sir, in that case,
look at that. If just any value, any age value, you will get triplet. What is the triplet? For example, what I said, in case of you check x equal to 25. Young age will be, what will be the young age membership value? X equal to 25. Just put that value, 10 by 15.
10 by 15, yes.
That is 0.67, right?
Yes, sir.
For middle age, it will be 0.33.
Hmm.
Yes or no? And
Yes.
for old age, it is 0. Right?
Hmm.
So
Yes, sir.
in this case, for each and every value in between 0 to 80, you will get a triplet,
Hmm.
3 dimensions.
Yes.
For young membership, you have new young, new middle aged, and new old aged. Agree?
Yes, sir.
Now you do the clustering, whatever you have learned last 2 classes. Then one group is for the middle aged, one group is for the young age, another group is for the old age. Got the idea?
Yes, sir. So, sir, here in instead of a Cartesian coordinates of position, we have this triplet of membership functions.
Yes, just you have to put that value over here and you will get the membership value in between 0 to 1. And take that value for the clustering, the dimensions.
Okay, sir.
Okay, then you can see that it's widely segregated. That young is a different group, middle age is another group, and another is old age, right? So 3 levels will be there.
Yes, sir.
Okay,
Yes, sir.
so let's see. What is normal fuzzy set? It's also important. Normal fuzzy set is one. Those membership function has at least one element x in the universe whose membership value is unique. That means in this case, 2 pictures are there. Tell me, which one is the normal fuzzy set?
Sir, A.
A, very good. Because B, there is no such unit. So its normality is false. Next one, very, very important, convex fuzzy set. Note it down. Whose membership values are strictly monotonically increasing, they strictly forget about that. It's written in quite theoretically, yes, it's possible, but the second definition, concentrate on the second definition. For any elements x, y, z in the x-axis, x coordinate, x, y, z, such that x is less than y is less than z. This is the relation, right? Now, mu a y should be greater than equal to minimum of mu a x and mu a z. Then A is said to be a convex fuzzy set. X, Y, Z, position wise, X is very close to origin, Y is far from X, far from origin, and Z is farthest from origin, right? In the X axis. Now, what will happen? Mu a Y, if you want to find out the Y coordinate, just corresponding Y values, that is the membership value, mu a Y will be greater than equal to minimum of mu a x and mu a z. Then this A set, that is the fuzzy set, will be denoted as convex fuzzy set. So it has been written theoretically that is strictly monotonically increasing, strictly monotonically decreasing in this way. So let's see. Please note it down the last part. There is a said another way. Any elements x, y, z. This part is very, very important to define the convex fuzzy set. There is a very important property of convex fuzzy set which will be applied numerous times in various applications. What is the important property? The intersection of those two convex fuzzy set is also a convex fuzzy set. Keep it in mind, very, very important. The intersection of two convex fuzzy sets is a convex fuzzy set. I'll show you. Have you written it? This one.
Yes, sir.
Okay. So let's see. Look at that example. One is convex normal fuzzy set, another is non-convex normal fuzzy set. What is normal fuzzy set? That means there should be a one value for which it will be reached to 1. Yes. Now mu, what is the definition? Mu a y. Mu a y. Yes. Then greater than equal to minimum of these two. Greater than equal to means mu a xy, this value and this value greater than equal to this one. That's why it is a convex fuzzy set. Why it is called normal fuzzy set? Because at least one value for which it would reach 1. What is the membership function? What here? Can you tell me, anyone?
It's triangular.
Very good, triangular. Very good, triangular. But second picture, look at that. It's a normal fuzzy set because one value is there unique, but it's a non-convex. Why non-convex? Mu a y, but these two, minimum of these two, mu a x and mu a z, these two, minimum of these two, suppose this one is minimum z, mu a z, is greater than mu a y. So that property not reflect. That's why it is non-convex. Got it?
Sir, is this called convex because of the shape of the curve?
This one is not convex.
I mean, is there any special reason for calling convex the term convex?
Convex only for this one. We check it. This one. Look at that. That property. Two functions are there, A and B. Two fuzzy sets are there. A is a fuzzy set, B is a fuzzy set. Both are the convex fuzzy set. And their intersection is this one, bold. This triangle, inner triangle. It's also convex. But it doesn't guarantee that it should be unique, or that means it's a normal fuzzy set. I am talking about this property.
Okay, sir.
So defuzzification, if you just go through it, look at that. There are a lot of methods are there. Center of sums, center of gravity. We are basically concentrating on center of gravity, COG, and maximum methods, weighted center of area. So look at that. COG, center of area, center of gravity, this method. X star is there, that gives the center, or this is the Chris value. But before going to that part, if this discrete membership function, then we have to go for summation. And if it is a continuous membership function, then we have to go for integral, that I discussed. So this is the area. So how do you, why it is, look at that. Two fuzzy sets are there, C1 and C2, right? C1 and C2, and these are the area denoted by A1 and A2. This is the combined fuzzy set. Same framework, look at that, 0 to 9, and this one is 0 to 0.5. So 0 to 9, two fuzzy sets are there. If we want to combine it, this two fuzzy set, it will be look like this, right? Agree?
Sir, can you show the previous slide once?
Yes, yes, this one. It needs the concept of coordinate geometry. Try to understand defuzzification. That means multiple fuzzy sets are there, and you want to combine it, and finally there should be a center that will represent the fuzzy set, a single value that will represent the entire combined fuzzy set. So which one will be the single value? How do you evaluate that single value that will represent the combined fuzzy set? That process is known as defuzzification. So here we have mentioned the input only two fuzzy sets. It can be possible for n number of fuzzy sets, or 10, 15, whatever. Then you have to combine it in a framework, and then you have to find out what will be the centroid or center of this fuzzy set. And that process to evaluate the centroid of this combined fuzzy set is known as defuzzification. Got it? Yes or no? Hello.
Yes, sir. Yes, sir.
So that will be discussed in the next class. Okay. That will be discussed in the next class. So I will upload this note up to fuzzification in the Google Classroom. I think all of you have gone through this Google Classroom. All of you got it? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So you please. So what can I do? Can I do a roll call over here? Or all of you are present? At present, I have seen total 26 students are there. So can you tell me who are absent? Better to take attendance, otherwise better to take who are the absents. Absentees name. Total strength is? What is the total strength?
So total 34, I guess.
34. So
some of them have left actually. So মানে actually attend করে 30 জন স্যার।
ওকে, আবার জয়েনও করলো লেফট করে গিয়ে। তো একটু এটা স্ক্রিনশট কি তুলে নেবে তোমরা, আমায় একটু পাঠাবে ডেটাটা, কারা কারা প্রেজেন্ট আছে।
যে ফোন থেকে করছি সে একজন কেউ একজন স্ক্রিনশট নেয়, আমার তো ল্যাপটপ হচ্ছে না।
হয়েছে নেয়া?
হ্যাঁ স্যার, ডান।
আচ্ছা, সবাই নিয়ে নিয়েছো। আমার একটু ওই যখন রেজিস্টার খাতাটা মার্ক করে দিতে বলে, পরের দিন আমি যাব। কালকের আমি আসছি না, ঠিক আছে? কালকের ক্লাসটাই আজকে নিয়ে নিলাম। আর নেক্সট যেদিন আসবো তোমাদের বোধহয় স্যাটারডে আর একটা ক্লাস বোধহয় অ্যাসাইন হবে ইমেজ প্রসেসিং এর। তোমাদের বোধহয় ইমেজ প্রসেসিং আছে, তাই তো?
হ্যাঁ স্যার, বললো আপনার সেকেন্ড হাফে নিতে, আর ওই স্যারটি ফার্স্ট হাফে নেবে।
হ্যাঁ ঠিক আছে, তাহলে আমি নিয়ে নেবো সেইভাবে, ঠিক আছে?
তাহলে স্যার নেক্সট ক্লাস কি মানে নেক্সট স্যাটারডে?
নেক্সট স্যাটারডে হয়তো হবে, ঠিক আছে? নেক্সট স্যাটারডে, ঠিক আছে? আর উইকডেজে নেক্সট উইকে হবে না, তারপরের উইকে আমি দেখছি। তোমাদের পুজোর ছুটি কবে পড়ছে?
স্যার নেক্সট স্যাটারডে একটা ইভেন্ট আছে ক্যাম্পাসে, তো সেকেন্ড হাফেই হবে ওটা। মহলার আগের দিন পড়ছে ওটা, 20 তারিখ।
মহলা কি রবিবার পড়েছে?
মহলার আগের দিন হচ্ছে, মহলার রবিবার পড়েছে।